This meeting is being recorded.
In this first video from chapter 16 about acid-base equilibria, we'll take a look at a brief review here of the different ways that we can classify acids and bases. So the first system here is the Arrhenius classification system, where an acid, once it's placed in water, and dissolved, would increase the hydrogen ion concentration. So that's what's indicated here. And then under this system, we have a base where when this substance is dissolved in water, again, this would now increase the hydroxide ion concentration. So that's one way of looking at acids and bases. We're also going to see them referred to as Bronsted-Lowry acids and bases in this chapter, where now we're looking at an acid in terms of it being a proton donor. So we have to think about the fact that it has to have a proton or an hydrogen without its electrons, H plus here, that's removable. We can also call that an acidic proton. So we'll get used to how to find those throughout compounds. And then when we consider a base in this system, this is now a proton acceptor. So now they must have a lone pair to accept the proton from the acid. So these are two different ways of looking at acids and bases, either the Arrhenius or the Bronsted-Lowry classification system. So let's take a look here. Let's see what happens when an acid dissolves in water. So we see here we have HCl gas, and we're adding liquid water. So what we get on this side is aqueous chloride ions and hydronium ions. So I said above that it's hydrogen ions, but it's really when you think about acids, the hydronium ions, H3O+, but we commonly shorten it to just H+, because we know there's also water involved, but this is just quicker to write. So you might see that notation as well, but we really mean hydronium. So this is what happens whenever an acid is dissolved in water. We'll get the conjugate base. In this case here, it's the chloride ion here is our Cb, and then our conjugate acid to water, which is the base over here, the hydronium ion seen on the product side. So when we talk about acid and base reactions, we can always relate the acid to its conjugate base, so its pair with a base over here, and then we can relate our base with its conjugate acid over there. So we'll always have these pairs, these conjugates. These are meant to be pairs, or in Latin it translates to join together. So we should note that reactions between acids and bases, in the case above it was water acting as a base, will always yield their conjugate bases and acids. So that's how we know what we should find on the product side. And there's one other definition here that you should note, this term amphiprotic. So some species, such as water, can gain or lose a proton. So water does have that acidic proton that we mentioned previously. So these species can therefore act as acids or bases. There's some other examples here: bicarbonate, bisulfate. Both of these other species here, in addition to water, can also gain or lose a proton. So we'll take a look at the next video, a couple of exercises.